Uniswap liquid providers lost over 100 million last year just because AMMs react to real world event after arbitrage bots have already exploited them. We built a Oracle aware liquidity infrastructure that flips this. Pools now adjust prices based on real world data before markets price it in. Real world events hit instantly, but AMMs react late. Markets adjust fast, bots move even faster, and by the time the AMM updates, liquid providers have already taken the loss. Liquid providers are always the last to know and they pay for it through LVR. This delay isn't glitch, it's a built-in weakness of AMM's architecture. Solution is simple. We feed real-world data straight into a AMM through Uniswap V4 hook and Flare oracles. As soon as the event is verified, the hook updates the pool instantly. Any bot that tries to arbitrage is forced to pay a dynamic fee equal to its unfair advantage. Bots lose the advantage, liquid providers keep their value, and the capture fees fund insurance. The solution is only possible in Flare because it gives you ultra cheap, high frequency, real world data through FDC and FTSO. Ethereum and Chainlink can't match the cost, speed, or native verification, so the model becomes economically impossible anywhere else. To demonstrate the use case of our protocol, we have taken the agriculture drought scenario where we integrated all four primitives of Flare. Let's start with an example of Brazil's farmer João. We use F assets to let farmers bring Bitcoin into the EVM as trustless FBTC. They can use FBTC as clean collateral for their crop insurance. Uh, but for the demo, I will be using C2FLR for simplicity. You can see FTSO price is here, which updates 3 minutes every 3 minutes. Now we will onboard the farmer. We just don't take the name, we capture his exact GPS coordinate and hash them into the region ID on chain. This binds his insurance policy to a specific 10 km square of land using the Flare data connector. This means his protection is tied to physical reality, not paperwork. You can see the now the situation is normal, so the swap charge is 0.1% standard. But now I will simulate a draft situation, the crisis situation. Let's see what happens. If I click the simulate draft button, then you can see FDC consensus confirms a severe draft in the area. To eliminate single point of failure, our contract demand a cryptographic consensus from three separate providers. If the satellite don't agree, the payout doesn't happen. Identifies the arbitrage opportunity and instantly reconfigures the contract, spike the fee to 50%. Now I will simulate a bot instead attack. Of blocking the trade, our Uniswap V4 hook allows it but force the bot to pay the full arbitrage gap as a fee. We just captured the bot's profit and moved it into insurance treasury. We turned the toxic flow into protocol revenue. Now what we will do is basically claim the payout of the farmer. You can see the like stuff in terminal that the everything is registered on chain. Yeah, you the farmer got the payout. It is fully deployed on Flare. Cost onto we used FDC for weather verification, FTSO for base pricing, and FSS for hard asset collateral. Thank you. You can check the contract address from here. Let me walk you through the all mathematical innovation features of our contract. First is circuit breaker, which has three mode protection that scales from dynamic fees at small gaps to compete trading fees at catastrophic gaps. Quadratic bonus system, rewards for fixing frozen pools grow exponentially with problem severity. Create urgency where it matters most. Well, protection system protects both LP positions and physical crops using the same FDC verification sources. Premium adjust in real time based on current weather, historical draft data, and treasury utilization, and bots try to exploit farmers end up funding their insurance. To use Flare DeFi, a farmer need to learn about blockchain, install MetaMask, create new wallet and stuff. So we solve this problem using Smart Account. With Smart Account, Zhao uses his existing XPRL wallet. That's it. So you can see the transaction hash here. If I click on the link, you will see. I will show you. Yeah, you can see the transaction is happening, but somehow the operator function is not working in the testnet. So